So in the next example, I want to show how instead of using this low-level Plutus, the untyped version, we can use a typed version. So I copied the example that we just looked at into a new module called typed. And this is just the validator we just saw. And all these three arguments are of the same type, data, and that is really very unpleasant and very un-Haskell-like. It almost feels like programming in a untyped language like JavaScript or Python. And what we would like is strong types here, so that only redeemers and data that actually make sense are expressible. And it's especially bad with this third argument, the context, because even though it's easy to imagine that you can somehow encode a transaction and its inputs and outputs into this data type, it's not at all clear how that is done. And it would be very complicated to understand that encoding and then use it in the business logic of the validator. Luckily, we don't have to, and nobody would. Instead, we would use a typed version. So instead of data, I just pick a type for the datum. Let's pick the unit type, which makes sense because we completely ignore it in this validator. And here, let's pick integer for the redeemer. And instead of datum, there is a type called script context, which is much nicer. And also, I explained earlier that it's very un-Haskell-like to have a unit return type, and that is also nicer in the typed version of Plutus. There it's bool. So it's as one would expect. If the result is false, validation fails, and if the result is true, validation succeeds. Now, to convert this into this version, the easiest would be to simply say r equals 42. So r is now an integer, no longer data, so I can compare it to 42, and if it is equals 42, the result is true and validation succeeds, and if it's not 42, then validation fails. This, however, would have the same problem that we had before when we just used error, that in the case of failure, we don't get a nice error message. But there's a nice Plutus function called trace if false. So if it's Plutus tx prelude trace if false, and we see that takes a string and a boolean and returns a boolean. So the idea is, if this boolean is true, the result is just true and the string is ignored. However, if this boolean is false, then the result will be false, but this string will be locked. And this is exactly what we want here. So we can use wrong redeemer again as our string. And then we use this condition. Okay, a typo, trace is false. Okay. And that compiles. Next, we need to adapt our boilerplate. And this, unfortunately, in the type version is more complicated and cumbersome. So let's look at this. First of all, we need something that we haven't used before. We introduce a dummy data type. I called it typed now because of the module name. And we must provide an instance of a class called validator types for this dummy data type. And the purpose of this instance is to somehow wrap together, package together the datum type and the redeemer type. So we give a type instance for the datum type, in our case that's unit, and we give a type instance for the redeemer type, in our case it's integer. So this basically just makes a parcel out of these two types. Next, we want to compile, and where earlier we used this make validator script function, now we use something called make typed validator. And the result is no longer a validator, it's of type typed validator, and that takes as type parameter this type that we defined here. It's relatively similar. So first we have to give as a type argument this type. This line is as before, more or less. So we again use Plutus tx compile, and of make validator is again with the Oxford brackets and the $$. But now we also somehow have to provide a way to interpret this typed as untyped. So the boilerplate for this looks like this. So we have another argument where we again compile a wrap function, and the wrap function uses a function that's provided by the Plutus libraries that's called wrap validator, and that also needs two type arguments, which are again the datum type and the redeemer type. So this is also boilerplate, and it's always the same, so you can always copy paste that. Now in order to get the validator from a typed validator, we can use a function called validator script, and it takes a typed validator and turns it into an untyped validator, as we have seen before. To get the hash, we could of course use the validator we now have and then turn that into a validator hash as we did before, but there's also a more direct way. There's another function called validator hash that's now in a different module, even though it has the same name. It's in the typed version of the script in ledger.type.scripts, and it takes the typed validator and produces the validator hash. And finally, the address, that's as before, so we take the validator and apply the script address function to it. So admittedly, this example doesn't really demonstrate nicely why we would bother with typed validation instead of untyped as we had before, because the boilerplate is much more complicated and we don't really see an obvious advantage. I mean, we save 2 lines of code, but it barely seems worth it. But of course, if you have more realistic, more complex examples, then it becomes more and more helpful if you can use specific types that are suited to your business case of the validation logic and don't have to bother with this blob type data. And then it becomes much more useful. So in practice, all validation scripts or other scripts in Plutus will use this typed version. The untyped version will never be used. Finally, let's look at the off-chain code. That is almost identical to what we had before. There's one slight change here in this line. Earlier we had must pay to other script, but now that we use a typed validator, there are special convenience functions for the common case that one script is especially important in off-chain code. I mean, sometimes you deal with more than one, but often the off-chain code is about one specific script, and then there's this function must pay to the script instead of to other script. And that has the advantage that you don't have to provide the datum as data, but you can provide the datum with the type that you used in the type validator. So in our case, unit. So I can just use unit here. Apart from that, I believe everything else is the same as before. And if we check in the REPL, it also compiles. Now we could try that in the playground, but I think it's not interesting because the behavior of this code will be exactly as before. So if we provide 42, then the grab will succeed, and if we provide a different value, then it will fail. So in the playground, you won't be able to see a difference. It behaves exactly as before. Next, let's try to understand how this actually works. So the typed validators are just a thin layer on top of the untyped ones. And this wrap function, or rather the wrap validator function, converts a function of this type, of a typed validator, into an untyped version. And in order to do that, it's obvious that somehow you need to convert the datum with the redeemer type, in our case unit and integer, into data and script context as well. So this wrap, basically what it does is it takes the data arguments that it gets in the untyped version, converts them into, in this case, unit, integer, and script context, then runs the typed make validator function, and then if there's an exception, it will return, if there's false, it will throw an exception, and if the result is true, it will return true, unit. So we need a way, or there must be a way to convert between at least unit and integer and data. And this is done by a class called isData. This is in module plutostx.isData.class. And this class has two functions, toData and fromData. So toData, so if a type A is an instance of this class, then toData of an A will convert this into a data, and fromData given a data will try to convert it back into an A. And this can fail, so we have this maybe type here. So if it succeeds, we get just the A, and if it fails, we get nothing. We can try this in the REPL. So let's import Plutus TX, and Plutus TX is data class. So we can look for is data here as well, and we see more or less the same that we saw in the documentation. And in particular, we see that there are some predefined instances. For example, int and bool and integer, and unit should also be somewhere here. So this explains why it worked out of the box for integer and unit as in our example. Now let's play with this toData and fromData a bit. So for example, we can try toData of 42, the integer. Let's make sure it is an integer. And we get I42, which is not surprising. That's what we did by hand before. So when we worked with integers as a data value, we use the I constructor. It should also work the other way around. So if I do fromData I42, now I must help the compiler and tell it what type I expect. So I expect the maybe integer. Then it succeeds, so I get a just and 42. In order to see it fail, let's take another constructor, for example, the list constructor with an empty list, and that fails. So this doesn't correspond to an integer, so we get nothing. And we see here that there are some predefined types that have instances. And that's, as I said, the reason why it worked in our example. But of course, this is still not completely satisfactory, because what we really want is we want to use custom data types that are well suited for the validator we want to write. And in order for that to work, normally we would have to write by hand instances for the isData class for these custom types, which is quite tedious and also quite mechanical. So we don't really want to do that. But the good news is we don't have to, because Plutus also provides an automatic mechanism to use custom types and make them instances of isData. So finally, let's look at how to make custom data types work with isData and typed validators. So I copied the type module under the name isData, and let's say instead of integer for redeemer, we want a custom data type. Let's use a simple new type, my silly redeemer, which just wraps an integer. And let's try to replace the integer here, where we have the redeemer, with this type. So in order to pattern match, we can just pattern match against this. So R is now an integer again, so this should still be correct. Here in the type instances, we have to replace the integer with my silly redeemer. Okay, this should be fine. Here, my silly redeemer. So that should be it for the off-chain code, on-chain code. Now for the off-chain code, we must just in the grep instance where we give the redeemer, we must somehow now provide the right thing there. And actually we don't really know what to write there. So what we can do is toData of my silly redeemer R. So if we now try to load that module, we do get, okay, first we get the error that is ambiguous. Let's call it Plutus TX toData. Okay, typo. Okay, but now we get the error message that no instance of isData for this class, mySillyRedeemer. In order to fix that, we could write an instance for isData of mySillyRedeemer by hand, which in this case would be relatively straightforward because we could somehow reuse the one for integer. But we don't have to. Instead, we can use Plutus_tx unstable make isData, which is again a function using template Haskell, like this. Let's first see whether it works. Yes, now it compiles. So this is a template Haskell function, and it takes a type. And the syntax to provide a type is to use 2 single quotes in front of the name of the type. And this will then, at compile time, write an instance for isData for this type and splice it in here at this point. So this is as if we manually, at this position here in the source code, had written an instance for isData. And now actually we should be able to try that out as well. So if we again import Plutus_tx and Plutus_tx isData class, and now do something like toData mySillyRedeemer42, then it works. And we see it doesn't just what we might have expected, reuse the instance for integer. So in that case, it would just be i42, but it uses the constructor of the data class. So that's not obvious, maybe, but that's how it's done. Okay, so, and this of course works for other custom types as well. So using this Plutus template Haskell function unstable make isData, we can turn custom data types into instances of isData and then use them in our validator scripts, in our typed validators. In case you're wondering why it's called unstable, there's also a stable version which you should use in production code. So this is about constructors. We saw that in this case the mySillyRedeemer constructor was translated into constructor 0. I suppose if there's only one constructor for a data type, it will always be 0. But if there are several constructors, it's not so clear in how they are ordered. And the difference between the unstable and the stable version is that the unstable version does not make any guarantees that between different Plutus versions, the constructor number corresponding to a given constructor will be preserved. And that of course would be bad, because if you use an older version of Plutus to serialize something to data, and then a newer version of Plutus makes it in a different way, does that in a different way, then it would be incompatible and you would have round-trip problems. And if you use the stable version, then you can explicitly specify which constructor corresponds to which index. So then it's guaranteed to work between different versions of Plutus. But for now, for quick and dirty trying, I'll always use the unstable make isData. So let's quickly try this out in the playground, whether it still works as before. It should be exactly the same behavior. So I pasted the new code into the editor and compiled, and same scenario as before, first with the wrong redeemer. And yeah, we only get 2 transactions, and wallet 2 didn't successfully grab. Now let's provide the right redeemer and try again. Now we have 3 transactions, so the grab worked and the balances are also correct. So we see that both the untyped and the typed version behave exactly the same, but the typed version is much nicer to work with.